Hey, what's up guys? Nico here, back with another video. In today's video, I am going to expand upon my previous video, which introduced you guys to variables. So, if you hadn't checked that out yet, please click the annotation on screen or check the link in the description below. Also, in today's lesson, I will once again use an online Java compiler. So, if you guys want, you can click the link in the description and program alongside me. Now, with that out of the way, today we are going to expand upon our variable knowledge by discussing arithmetic operators, operands, assignment operators, and unary, or increment and decrement operators. Through understanding these concepts, we will be able to perform a multitude of calculations within Java. To start, an operand is any value or object that is capable of being manipulated. For example, if we write int num equals 2, then num and 2 are operands. An arithmetic operator is a mathematical function which performs a calculation on two operands. For example, if we write int num equals 2 plus 3, then in this scenario, 2 and 3 are the operands, and the addition sign is the arithmetic operator. First of all, note that Java obeys order of operations. This means that operations inside of parentheses are prioritized over operations outside of parentheses. Following parentheses, Java will prioritize the multiplication, division, and modulus operators. For those of you who are unfamiliar with the modulus operator, it will return the remainder of two numbers upon dividing them. For example, 10 mod 3 equals 1, as 10 divided by 3 equals 3 1/3, and 1/3 times 3 gives us a remainder of 1. 4 modulus 2 equals 0, as 4 divided by 2 results in a whole number, therefore we have no remainder. Lastly, Java will prioritize the addition and subtraction operators. Please note that if multiple operators have the same priority, such as addition and subtraction, or multiplication, division, and modulus, then Java will interpret them from left to right. So now we will go through several examples of calculations done within Java. If you guys want, feel free to pause the video right now and try to predict the answers to these equations. So now if we click the Visualize Execution button, you guys can indeed see that Java does follow order of operations. If any of you are still confused as to how Java calculated these values, please check the description below for further detail, where I will explain the order of operations step by step. Next, I wanted to talk about a simpler way of performing certain calculations. If one is performing only one calculation to a variable, then one can use what we call assignment operators. Now, the basic assignment operator is the equal sign, which assigns the value of the right operand to that of the left operand. If one wants to perform a calculation more efficiently, there is an assignment operator for all previously listed operators. The addition assignment operator will add the value of the right operand to the value of the left operand, and the subtraction assignment operator will subtract the value of the right operand from that of the left operand. In this example, I created a variable called num, which has been assigned a value of 3. On line 4, I wrote num plus equals 2, which means that a value of 2 is being added to num's current value, which is 3, thus giving num a value of 5. And as you can see, when I output num, it has indeed been assigned a value of 5. Next up, I created a variable called num2, to which I assigned it a value of 3. And on line 7, I write num2 minus equals 2, meaning that we are subtracting a value of 2 from num2's current value, which is 3. 3 minus 2 equals 1, meaning that num2's value is now 1. Once again, when I output num2, you can see that it has indeed been assigned a value of 1. Similar to the addition and subtraction assignment operators, we also have the multiplication assignment operator, which multiplies the value of the left operand by that of the right operand. We also have the division assignment operator, which divides the value of the left operand by that of the right operand. Lastly, we also have the modulus assignment operator, which sets the left operand equal to the remainder of the left operand divided by the right operand. In this example, I created a variable called num, which I assigned a value of 2. On line 4, I wrote num times equals 4, meaning the value of num, or 2, is being multiplied by 4. 2 times 4 equals 8. Therefore, num is equal to 8. And when I output num, you can see that it has indeed been assigned a value of 8. Next up, I created a variable called num2, which I set to a value of 30. On line 7, I wrote num2 divided by equals 6, meaning that num2's value is being divided by 6. 30 divided by 6 equals 5. Therefore, num2 equals 5. And when I output num2, you can see that it has indeed been assigned a value of 5. Lastly, I set num3 equal to 10. Num3 mod equals 3 sets the value of num3 to the remainder of num3 divided by 3, or the remainder of 10 divided by 3, which equals 1. Therefore, num3 equals 1. And when I output num3, you can see that it has been assigned a value of 1. Overall, assignment operators can be more efficient, as typing in num equals num plus 2 is less efficient than typing in num plus equals 2. Lastly, if one only needs to add or subtract a value of 1 from a variable, there is an even easier way of doing so. For this, we can use what we call increment and decrement, or unary operators. To add a value of 1 to a variable, one would write the variable name preceded by ++ semicolon. To subtract a value of 1 from a variable, one would write the variable name preceded by --- semicolon. For example, if we write int num equals 2 and then write num ++, we can see that we have added a value of 1 to num, thus making it equal to 3. Similarly, if we set num2 equal to 1 and we type in num2 minus, we have subtracted a value of 1 from num2, thus setting the value of num2 equal to 0. Now, I'm sure by this point in the video, a few of you may have been wondering, what about exponentials? Well, for exponentials, there is a function called math.pow, which accepts a double named a and a double named b, which returns the value a to the power of b. For example, math.pow with an a value of 2 and a b value of 3 will return a value of 8. As you can see, this indeed outputs a value of 8. To do root functions, note that one can either do math.sqrt for square roots or math.cbrt for cube roots. Now, what about more complicated roots, such as 3.5 or 10? In this scenario, one can simply make the b in math.pow 1.0 over the designated root. For example, a square root could be written as math.pow with an a value of 4 and a b value of 1 over 2. And a fourth root can be written as math.pow with an a value of 16 and a b value of 1 over 4. Now, one thing to note is that if we solve 2 to the power of 3 on paper, we know that it will give us an answer of 8, which is an integer. Although over here we have an answer of 8.0, which is a double being outputted. Now, the reason for this is that the math.pow function will always return a double, even if the answer is an integer. So although on paper we know that the answer is 8, which is an integer, it will still output that as a floating point value. Now, to wrap up this video, I wanted to quickly show you guys why I put 1.0 over the designated root as opposed to 1 over the designated root. And that's because if I put 1 over the designated root, both values are integers. Therefore, they will be interpreted as integers, which will round them down to 0. 0.25 or 1 over 4 will be rounded down to 0, and any number to the power of 0 will equal 1. But when I write 1.0, 1.0 being a double divided by an integer will still be interpreted as a double. Well, that just about wraps it up for this video. Thank you guys so much for watching. If you guys have any questions, please leave them in the comments below, and I will get back to you as soon as possible. Have a great day. Peace.